Hello, ladies, gentlemen, and in between, and welcome back to another episode of Maths with Hamblin with your beautiful host, Hamblin. And today, my boys, we're just going to be going over some practice problems involving the equation of a circle. It's going to be a riot. Let's have some fun. Okay, so this first question goes like this. A curve has equation x squared plus 8x plus y squared minus 4y equals 5. And we're asked in part A to show that the curve is actually a circle and find its radius and centre. So now, if you watch my last video, you remember that when you're faced with the equation of a curve that looks like this, where you've got some squared and some loose linear variables, you can just use completing the square to show that it's a circle, and then from the equation of the circle you can get its radius and its centre. So let's complete the square. So first of all, completing the square on this first bit with x, you get that this little bit here becomes x plus 4 squared minus 16. Don't believe me? Expand it. And this second bit becomes y minus 2 squared minus 4, and that needs to still equal 5. Okay, brilliant, we're almost halfway there. Now we've just got to add these terms onto the left to get it into the equation of the circle standard form that we derived last video. So if we do that, you get our final equation for the circle is x plus 4 squared plus y minus 2 squared equals 25. Now, if you recall, the centre of the circle is given by the minus of these two numbers. So the centre of the circle is in fact at negative 4, 2. Fantastic, and the radius of the circle, well, the radius squared equals this number on the end here. So r squared equals 25. In other words, the radius of the circle will be 5. How absolutely fantastic and easy. Anyway, on to part B after I erase this board. Okay, so part B says, verify that the point 0, 5 lies on the circle. Now, if you recall, for a point in the xy plane to lie on the circle, its x coordinate and its y coordinate has to satisfy the equation of the circle. So if we just plug 0 and 5 in here, and then we get 25 on the other side, we'll know that that point must be on the circle. So plugging in 0, we get that just 4 squared, plus, and then plugging in y equals 5, 5 minus 2 is 3, we get that 3 squared, and we want that to equal 25. I'll put a little question mark over the equals. 4 squared, 16. 3 squared, 9. Add them together, you get indeed 25. Absolutely fandabidozy. Okay, so this second problem goes like this. A curve has equation x squared plus y minus k squared equals 16, and where k is a constant, and we're asked to find the values of k, values, there's more than one, for which the curve contains the points negative 3, 12. Okay, so let's think about what's going on in this problem here. We've got the equation of the circle, and it has a centre at 0, k. So it's k units above the y-axis as its centre. So if we vary the constant k, we're going to shift the circle up and down the y-axis. And we need to find the exact amount of shifting we need to do in order that this point is contained within the circle. And that makes sense, right? That we get more than one value of k. In fact, you can think that we'd actually get two values of k, because you can imagine taking a point and then having a circle shift up and down. If you can shift it this much, and then the point might cross it, and then you can shift it even more, and then the point might cross it again. I hope you can understand what I'm saying. Anyway, so you can understand and see why there has to be more than one value of k. Anyway, so let's go on to solving this, shall we? So, if this point is going to lie on the curve, its coordinates must satisfy this equation. So, if we plug those coordinates in and solve, we're going to see what k must be for that point to actually be on the circle. So, let's do that. Plugging in minus 3, we get minus 3 squared, which is 9, and plus 12 minus k squared, and we need that to be equal to 16. Anyway, 16 minus 9, 7. 12 minus k squared equals 7. Take the square root on both sides, not forgetting the plus minus. And we get 12 minus k equals plus minus root 7. And then we can do a little bit of rearranging. I'll skip the details, and you get that k equals 12 plus or minus root 7, which is nasty, disgusting, but it's an answer. Anyway, thank you for watching this episode of Maths with Hamblin. I know it's just a short one. You don't need much practice for these kind of circle questions, so that's why it's a short video. Anyway, thank you very much for watching, and I'll see you in the next one. Goodbye!